Good afternoon, colleagues and learners. My lesson today will be on Euclidean geometry. I'm going to treat two theorems in grade 12 syllabus and two theorems in grade 11 syllabus. Right, the first theorem that I want us to look at, it's actually theorem 1 of the grade 12. It reads as follows. I hope you're watching me. The line drawn parallel to one side of a triangle cuts the other two sides so as to divide them in the same proportion. I want us to get this statement correct. I'll repeat. It reads as follows. It says the line drawn parallel to one side of a triangle cuts the other two sides so as to divide them in the same proportion. It is very, very important that when we tackle problems on theorems, if we are given statements, let us interpret, let's get the correct information from the statement. Let's get what the theorem is all about and what is the theorem requesting us to do. When we look at the first part of this, the first part talks about the line which is parallel to one side. It already tells us that in that triangle, there's going to be a line which is going to be parallel to the other side of a triangle. Now, if we look at this triangle, if we look at triangle ABC, it means inside triangle ABC, there has to be the line which is going to be drawn, which in this case it's line DE, which is going to be drawn from side AB and protrude to side AC, and eventually that line, which is now DE, it must be such that it becomes parallel to the other side. It must be parallel to the other side. If you look carefully at this stage, you look at DE having been produced, D being produced at side AB and E being produced at AC, such that when you join them, they make these two to be parallel. Now the statement went on to say a line drawn parallel to one side of a triangle cuts the other two sides, and that is basically what D and E has done to both AB and AC. D has cut AB at this point and E has cut this at this point. So we are told that this line, which now becomes parallel to this, it must divide these sides in the same proportion. What are those proportions? Proportion would be such that when you look at side AD over side DB, side AD over side DB, that must be equals to side AE over side EC. That is what is requested of us. This is what is requested of us. But before we can prove that theorem, I want us to come back to this. Let us quickly look at these two triangles. A triangle ABC and triangle DEF. With a little bit of knowledge, or with the knowledge that we had from grade 10 about having to determine the area of a triangle. The area of a triangle, we normally say the area of triangle is equals to half base multiplied by perpendicular height. Half base multiplied by perpendicular height. This is the formula that we normally use to determine the area of whatever triangle. Fine. Now let us quickly look at triangle ABC and check the side that will be referred to as the base and the height. When you look at triangle ABC, this is going to be our perpendicular height, H, which is written H, or which is denoted H, implying it's the perpendicular height. Why do we say it's perpendicular height? Because this is the height that must always be perpendicular to the base, and such that the angle there is always 90. When we say this is the perpendicular height, we say when you draw such a line, that line must be perpendicular to the base BC, and any line which is perpendicular to two lines which are perpendicular to each other, they must in between them have the angle which is equals to 90. So this is going to be our perpendicular height. Now, if we are going to determine the area of this triangle in terms of the formula, it means it's going to be half BC multiplied by height, which is our perpendicular height. Fine. That was the first triangle that we have gone through. Let's now come to the second triangle, which is triangle DEF. Triangle DEF. And we will also like to talk about the area of such a triangle. We'll also like to talk about the area of such a triangle. Now, if you look at this triangle alone, without having this extension, if you look at this triangle alone, it was otherwise going to be difficult for us to determine the perpendicular height for such. That's why we ended up having an extension. Remember, when we do this, we want to draw the line which will be eventually perpendicular, such that the angle in this case is also 90. So the perpendicular height of this triangle is outside the triangle, but when you look at the perpendicular height of this triangle, is within the triangle. So these are the two types of triangles that I would like us to look at before we can carry on with our theorem, because basically this is what the theorem entails. That is what the theorem that we are going to deal with it entails. Now, let us quickly look at what is requested of us, RTP, which is required to prove. The required to prove expect of us to have this, to say we're looking at, like, because we agree that this line divide these two sides into proportion. Therefore, we can come up with a rule in Yakhur. Then it means we are expected to prove that side AD over side DB. Remember, before the extension D, we only had like side AB. But because of this, we now have side AD over DB. This is, now we say side AB over DB over side AE over EC, or side AB over DB must be equals to, or must be in proportion with side AE over side EC. That is what is requested of us. Fine. Now we're looking at this triangle. That is the very same triangle that we had from our textbook. Remember, I've said that for us to prove that, we must always bring this into perspective, because we will not be able to prove that theorem if we are unable to identify in the mother triangle that looks like this, triangles which are going to appear in this form, because now we are going to have our extensions. Remember, what is some learners can say, but what is the reason for extension? The reason for extension is that we have just been given an ambiguous triangle that from it we don't have the perpendicular heights. Now we must come up with extensions or constructions such that we have perpendicular heights, because basically the theorem, it's all about areas. Now, for you to be able to prove a theorem that entails theorems, you must, for starters, be able to say, let me have constructions in this which will actually give me perpendicular height of certain triangles that I will not mention, but as we proceed, you'll be able to see that.